Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we entrust your brain with weird and wonderful science. I'm Ian Woolf. On this trustworthy edition, Nick Dirks, president of the New York Academy of Sciences, talks about public trust in science. But first, here's news about AI helping people speak their mind. Thought to text. Researchers from the University of Texas, Austin have trained a neural network model to convert functional magnetic resonance image scans from thoughts into text. The functional magnetic image scanner shows the pattern of how blood flow changes as you think by measuring blood oxygen levels at specific locations in your brain. The aim is to help people who are awake but unable to make their mouth and throat speak, such as those debilitated by strokes or other disabilities. The software uses the same kind of transformer models as chatbots like GPT and drawing programs like Stable Diffusion. The decoder uses scans from the classical language network, the parietal temporal occipital association network, and the prefrontal network in participants' brains. The team wanted to use functional magnetic resonance image scanning so that no surgical implants were needed. A problem they needed to overcome is that the blood oxygen level dependent signal they're measuring peaks for 10 seconds, whereas people speak English at a rate of over 2 words per second. This means every brain image could cover more than 20 words. The brain imaging isn't as fast as speech, so you end up with less images than words. They solved this problem by having the decoder guess at word sequences using GPT-1, encoding a brain image for each of the guessed word sequences, comparing them to the actual brain image, and then scoring the chances that each of these word sequences would cause that specific brain image. Then they selected the best scoring guess. Iterated enough times, they eventually got a good description of what the words heard or thought were actually trying to say. Oddly, they found that their decoder was very bad at pronouns. This might be caused by limitations of the GPT-1 language model, or it may end up being that pronouns are processed in a part of the brain that they didn't capture. To learn how the brain responds to a wide range of phrases, they recorded responses while the subject listened to 16 hours of naturally spoken narrative stories, also known as podcasts. As people listen to the words, the parts of their brain that decode the signals and understand them take in more oxygen from their blood, making a pattern that can be captured with a functional magnetic resonance image scanner. Another problem is that people need to stay very still for 2 hours at a time for over 16 sessions in the functional magnetic resonance image scanner. It's narrow and very noisy. They went through a lot of participants who couldn't resist twitching their fingers or toes, and unfortunately that muscle movement affects the data. As a result, they only had 3 people in the study. One of them, the team leader, who's naturally highly motivated to keep still and make things work. The researchers used audio stories from Modern Love and the Moth Radio Hour for the 16 hours of training data to keep participants interested and focused on the words. If someone's mind wandered, then the data becomes useless. The podcast episodes used to test the decoder were different to the episodes used to train the decoder. Previous attempts to capture words people are thinking has aimed at decoding information from electrical signals sent to the muscles or the intention to send electrical signals to their muscles by working out the sounds people intended their mouth and throat to make. This only detects a small number of words or phrases that have been flashed on the screen or played into headphones. This decoder is making sense of continuous language. The decoder doesn't work out the precise words you're thinking, instead it gets the gist of what you meant. A system I reported on earlier this year also used functional magnetic resonance imaging to decode blood flow in the visual regions of the brain as you looked at images or thought about images to reproduce a similar image. This decoder generates sentences that recover the meaning of speech you've heard, speech you've imagined, and even silent videos. In one test, they had participants imagine telling 5 one-minute stories while being recorded in the functional magnetic resonance image scanner, and again outside the scanner, so there would be a transcript of the story for reference. Researchers were able to match up which scanner images corresponded with each story by comparing the word sequences from the decoder with the transcripts of each story. In another test, participants watched 4 short films without sound while being recorded in the scanner. The researchers were able to match up the word sequences from the decoder software with the audio descriptions of the films. Many films come with an audio description of what's on the screen for people with a vision impairment. In the third test, participants were played 2 stories told by 2 different speakers at the same time, while being asked to only pay attention to one of the speakers. They were then played the same recording again and asked to switch attention to the other speaker's story. The decoder's predictions were much closer to the story they paid attention to than the story they were ignoring. If you can all too easily imagine police and border guards using these devices on people against their will, then rest assured the researchers are concerned about privacy. They found that the training process requires someone's cooperation, and the actual reading process also requires the subject's cooperation. If you don't pay full attention in the training, the decoder can't interpret your thoughts. The researchers found that if the participant was asked to try and stop the decoder from reading their thoughts, that methods like mentally listing off animals, telling us off a different story while the podcast was playing, stopped the decoder working. Doing calculations didn't stop the decoder working. If you move even a little, the decoder doesn't work. If the decoder hasn't been trained on your brain with your cooperation, it won't be able to read anything from your brain images. Here's Jerry Teng, PhD student at the University of Texas at Austin, one of the researchers on the project.
I think right now, while the technology is in such an early state, it's important to be proactive and get a head start on, for one, enacting policies that protect people's mental privacy, giving people a right to their thoughts and their brain data. We want to make sure that people only use these when they want to and it helps them. Yeah, we really want to push for the enactment of policies at both the government and industry levels to make sure that brain decoding respects the people's mental privacy and agency.
Of course, if you're in Guantanamo Bay, or another place where they could force you to stay still in the functional magnetic resonance imager scanner for over 16 hours, then you're already in deep trouble with unreasonable people. The final results are that about half the time, when the decoder has been trained to monitor a participant's brain activity, the machine produces text that closely, and sometimes precisely, matches the intended meanings of the original words. In experiments, a participant listening to a speaker say, "I don't have my driver's license yet," had their thoughts translated as, "She has not even started to learn to drive yet." Listening to the words, "I didn't know whether to scream, cry, or run away. Instead I said, 'Leave me alone,' was decoded as, started to scream and cry, and then she just said, 'I told you to leave me alone.'" The researchers next want to try training the decoder on a bilingual participant hearing English podcasts, but then see if the trained decoder can interpret what that person understands of what they hear in a podcast in their second language. Currently, the huge size of functional magnetic resonance imaging machines and the amount of time you need to spend inside the machine make the decoder less useful outside of the laboratory or hospital. In 2019, I interviewed a researcher from the Hunter Institute in Australia who developed a portable functional magnetic resonance image scanner for ambulances. However, the researchers are thinking they may be able to train their system on images from functional near-infrared spectroscopy, which is even more portable. Functional near-infrared spectroscopy also measures whether there's more or less blood flow in different parts of the brain, but at lower resolution than functional magnetic resonance imaging. The paper was titled Semantic Reconstruction of Continuous Language from Non-Invasive Brain Recordings and was published in the journal Nature.
You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com.
Science, policy and public trust. Science is at the forefront of everything in society these days, whether it's technology, new knowledge, lack of knowledge, or challenges that we face. Nick Dirks is president of the New York Academy of Sciences, professor of history and anthropology, and formerly chancellor of the University of California, Berkeley. I spoke with him by Zoom and began by asking him, there's the pandemic and the climate emergency, the interest in artificial intelligence and all these things, and there seems to be a lot of people turning away from trusting experts, almost like it's a movement. Or a mental virus, I don't know, where people, on the one hand, they want to be skeptical, but not in a critical, skeptical sort of thinking for yourself sort of way.
I mean, all three of them raise questions of existential risk. All three of them have been accompanied by apocalyptic thinking.
Yes.
And, when you start thinking about the apocalypse, the move from science to something really quite different happens pretty quickly. So
why is it you think that there's a little bit of a crisis of trust in science and expertise at a time when we need our experts the most?
It's a really, really good question, and one that I've been thinking a lot about, but of course not alone, since I think the pandemic was an extraordinary example of a time when science rose to the challenge. It was remarkable how quickly we were able to roll out vaccines that had extraordinary safety and extraordinary effectiveness against this novel virus. At the same time that we saw with the rollout, with all the efforts on the part of public health officials to translate what was becoming known about the virus and how to deal with it, how it spread, and what it did, it's extraordinary that, of course, with all of that knowledge and with that demonstration of science's amazing power, we saw a growing level of distrust of a kind that I don't think we've really seen for a very long time. It's not that it isn't precedented in all kinds of respects. Certainly in the US, we've had many, many examples over the centuries of times when science was seen as, basically in league with the devil, whether it was, Darwin and Darwinianism, and then this famous Scopes trial that took place in the 1920s, when basically the teaching of evolution became a cause célèbre on the part of a certain kind of religious right wing. But, that was 100 years ago. Science has done amazing things since then. And again, as we were just saying, it did them in connection with the response to this unprecedented pandemic. But levels of trust seem to be as high as ever, if not higher. So why is that? And of course, it's not unrelated to a kind of distrust in institutions across the board. It's an illustration of distrust in institutions and expertise and the conditions of how experts attain their level of authority and what that authority then translates into. But some of it is about not so much the science, but about the way science has been used to formulate policy. So, people listen to science. It seems to change all the time. It seems to be uncertain. But then, you get these kinds of messages saying, follow the science, as if there's a single thing. And then the science becomes science policy: wear masks, social distance, take a vaccine that has never been used before, that has been rolled out and very quickly given trials, but nevertheless, never really, mRNA vaccines were not used before. This was the first time they were successful, but it was also the first time they were used. So, I think from my point of view, and again, I'm a social scientist, so I think about the social and cultural surround of science as much as I think about science itself. I think one has to actually look at, the kind of systemic causes of current levels of distrust. And I think then it becomes an issue for scientists and certainly for science writers, science communicators, science journalists, to figure out better ways to communicate both the process of science and the relationship between scientific knowledge and then scientific policy, because they're not always the same thing.
I think a lot of people at the beginning of the pandemic, if they paid attention to international news, which some people did more and some people did less, they found some inconsistencies in the policies because of uncertainties in the science. So social distancing. In some countries it was 1 metre, and some it was 2 metres. And that seemed very arbitrary, kind of because it was. People were taking guesses, and different public servants came up with a different conclusion from what they'd read. But it's the sort of thing that people start to wonder how much of it isn't true. And now there's people still, this many, 3 and a bit years in, saying that, COVID was mass hysteria or that it's not so bad. So how do we get past... You need the uncertainty in science to be honest with the public about where there is uncertainty. But on the other hand, you want to have people understand that this is a reliable system of knowledge.
Yeah, I think uncertainty is a real problem for most people. They think of science as either the truth or not the truth. I mean, it's a kind of Manichaean way of looking at it. And unfortunately, even in our schools, we teach the scientific method as if somehow the scientific method will lead to the scientific truth at the end of it. Is, again, how we learn science to some extent. But how we see science, how we experience science as ordinary citizens, is to read journalistic pieces about studies that have been done of diet, of exercise, of different kinds of diseases and possible relationships between disease and everything from environment to lifestyle. And we see that things and judgments about these things change almost on a weekly basis. And so, you begin to think there's almost something faddish, not so much about the way we, have our diets or think about our exercises, but our exercising routines, but about actually the way science itself is conducted. So uncertainty is very difficult to grasp and then to accord the level of authority that we, direct towards science, particularly during times of emergency. And at a time of emergency, it really is a guess on the one hand, but on the other hand, it's an educated guess, and it's a guess that could save lives. And we know that masking did save lives in the early days. And we know that social distancing, whether it was 1 meter or 2 or 3, slowed the transmission of the disease, particularly at a time when we didn't know how to treat it and we didn't have vaccines for it. But still, it was emerging, it was evolving, it was science in real time. And it makes people nervous. It makes all of us nervous. And I think it even made scientists nervous to know as little as they did. And they were, trying to figure out very, very quickly, and again, in not only real time, but in very public view, what this virus was doing to us and how we might be able to respond to it. So again, the challenge here is to be honest about uncertainty, but probably to find better ways to talk about scientific consensus and really focus on what consensus means. You have a group of experts, they don't all agree, But on certain things, they do come to accept a certain kind of consensus view about, it's better to take a vaccine with all the risks that might be attendant to it than not to. And you can look at the charts and you can look at probabilities about the vectors of disease transmission, or you can look at the relationship between the vaccinated and the unvaccinated, and every now and then you see something that really does command your attention, which is in this case the vast difference between the level of seriousness of the disease and outcomes from the disease, and whether you were vaccinated or not. And that's something I think that one has to be able to focus on at the same time that one can accept and acknowledge the extent to which our understandings are emergent. They're constantly being tested. The reason that scientists are often uncertain about things is because the scientific method is about testing. It's actually about experimentation. Now, these are things that scientists know, but we don't always do a very good job of explaining how those relationships really work. Again, in a real-time situation in which, unfortunately, the decisions that you make and the educated guesses you take have really critical implications for individual and collective health.
I think there's been a really big failure in explaining things like public health to the public, so that, for example, what a vaccine is and what it does, people have had a particular idea that vaccines, that you take them once, they protect you from catching a disease and spreading a disease, and anything that doesn't do those things isn't really a vaccine. So when we have a COVID vaccine that stops you getting severely ill and perhaps having to go to hospital or even dying, but doesn't stop you spreading the disease and doesn't stop you catching it, people get confused because it breaks their idea of what a vaccine is, even that's not the limits of what a vaccine always has been for every disease that we vaccinate against.
Yeah, no. I think I think in that sense you're absolutely right. One has to be very clear that a vaccine is not about protecting you from catching or transmitting a disease, but really it's about reducing the severity of that disease if in fact you do get it. But the other part here is that something about vaccines really does create, in some instances, public hysteria. The idea about introducing some foreign substance into your body that is going to be, working in mysterious ways to do whatever it is something that for almost as long as we've had vaccines has occasioned, very serious reactions. In terms of the history of vaccines, I think the miracle that took place very early in my lifetime was the polio vaccine. And I'm old enough that that I remember taking the first polio vaccine when I was a toddler. But I remember after that being told by my mother I didn't have to worry about going to the swimming pool in the summertime, because she was always worried about the possibility of polio. However, when the polio vaccine was developed, one of the first 6 initial batches was contaminated and not only didn't work, but actually spread polio to kids who had taken the vaccine. And it was an enormous defeat. At a moment of great and spectacular success for science, there was that that introduction of human error that I think was associated with many with the very miracle of the vaccine itself. And since then we've seen controversies over vaccines for measles and mumps and rubella that associate vaccines with autism. And more recently, I've heard even from people in the field of biological research, because of the element of alum that is in the vaccine, that there are some correlations potentially between vaccines and allergies of one kind or another. Now, science is going to deal with that by testing and by trying to evaluate and so on. But then you get that article that came out in Lancet and making a correlation that was spurious and on the basis of fraudulent scientific data between a vaccine and autism, and it explodes.
That was part one of my conversation with Nick Dirks, President of the New York Academy of Sciences and Professor of History and Anthropology, talking about the problem of public trust in science. Listen for part two next week.
And that's all from us this week on Diffusion. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please subscribe to the Diffusion Science Radio channel on youtube.com/c/diffusionradio and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. The news music was Rhinos Theme by Kevin MacLeod of Incompetech.com. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including Radio Blue Mountains 89.1 FM in New South Wales, 8CCC in Alice Springs and Tennant Creek, 2MVR in Nambucca Valley, 3MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, and 2XXFM in Canberra. Diffusion is narrowcast on Indigo FM 88 in northeast Victoria. Diffusion is syndicated globally on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Make a donation through paypal.me/IanWolf, or join my patrons at patreon.com/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits: photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.